Hi and welcome back. Recently I've been asked a lot to do a tutorial about a AR indoor navigation video on my channel. The link is in the description box. So I decided to just do some kind of short tutorial. I've not really prepared for this, so this is just a quick shot. Don't wonder if I have a few mistakes in there. I will just cut the video so that you have the most information out of it and a working prototype at the end. Don't waste any more time and let's get started. So first of all, I created an empty Unity project with the 3D template, and we'll try to do the basic settings for getting started with ARFoundation and ARCore. So at the player settings, at the Android settings, we're just removing the Vulkan API at first. Then switch dynamic batching on. Everything else looks good. Make sure to use at least Android 7 for the minimum API level, the scripting backend to IL to CPP and the API to .NET framework, target architecture to RM64, and I think all the other settings are fine. For easier handling, we'll just use the old input manager. Feel free to change that to the new one. And that's basically it. So we can switch to the Android platform now. Go to build settings, select Android, switch platform, and wait for it to finish. Add the sample scene here. Close build settings, go back to the player settings, install the XR plugin management, and beneath Android just check ARCore to have all the XR ARCore packages imported. Next step is to open the package manager and install ARFoundation from the Unity registry. Here we go. As we see, the ARCore XR plugin is already installed. ARFoundation will be installed now. If you look for samples, they are available at the Unity GitHub repository. We won't need them here. So delete the main camera, right click XR AR session origin for our AR camera, and the AR session added the same way. And we'll see here the AR session and the input manager. If we need something else like the AR anchor manager for AR anchors, we can add it here, but I'll just leave it out now to show that it works basically without everything else. And that's everything we have to do for ARFoundation to get it working. Next is to create a new folder, call it textures. We'll add a minimap texture here. I just created a minimap texture in Paint from my current hotel room. It's not very accurate from the measurements, but it will do, I guess. Just drag it in here and change it from default to sprite to the NUI texture type to make it usable as a minimap preview. Here we go. Yeah, looks good. And right click in the hierarchy, 3D object cube. This will be our floor cube. Yes, just make it a floor cube and reset it from the position and make it in the scale in the y-axis 0.01, x-axis 6 and z-axis 3. This will more or less be the measurements of my hotel room at the moment. This looks good. And now we're going to add the minimap to our floor to have some kind of overview. Create a new folder, call it materials, and within the materials folder we add a new material. Floor mat. Oh, forget the mat, just call it floor. And switch the shader to unlit texture and select the casual map, the minimap. And we'll see when we add our material to the floor cube. Okay, we have to turn it around 180 degrees. That this already looks like a minimap to us. Just leave it for now, create a new empty game object, call it environment, reset it, and make the floor cube a child. And again, add a cube to the environment as a child. This cube will basically be our walls. Just add it to isometric view now. Just change it to isometric view now for easier placement. And we'll place the cube here, scale it down the thickness to about 0.06. Must not be exactly, but make it sure that everything at the wall cube aligns accordingly to our minimap or to our floor plan, or however you call it. Duplicate it, move it to the other side, duplicate it again, and just rebuild the geometry of this room. Here we go. Just a few little adjustments. You can feel free to create your own map of your own room or floor, however, and align the cubes accordingly. Here we go. Just change the set scaling to 0.06 for the horizontal walls. Scale it up in the X dimension. Here we go. Move it to the top. Nice. Duplicate it. Move it down. So we basically have a room finished. No, the interior walls are missing. Okay, duplicate it, scale it. Place one on the interior, on the inner walls. And then finish up the door to the bathroom. I'll just try to make it as close to the floor plan as possible. That looks good. Half of the walls are throughout the floor, so we'll just have to move them up a little bit and make them bigger. Around 2 meters high. They're actually higher, but that doesn't really matter now. Move it up 1, and so here's basically a very simple model of our room. Create a new material here for our walls, as we want the walls to only occlude and not be visible. Right click, create material, call it wall, and now that's a very cool trick. Go to shader, VR, spatial mapping, and occlusion. So everything that has this material will be invisible but will still occlude other things, and that's exactly what we want. We want some kind of invisible walls in our AR application. No need to cast shadows, no need to receive shadows. Well, let's do it like this. It's basically fine. So let's make our environment static, because we want to switch to a navigation mesh, and we basically want to have a navigation mesh on our floor cube, which originates in the upper left corner and gets to the bathroom. So moving the geometry so that the starting point 0, 0, 0 in world aligns with our starting point on the geometry. Just aligning it a little bit more, and I would say our target should then be in the bathroom, well, to do some navigation part of this, yes. The next part will be to add our navigation mesh, move to Window, AI, and Navigation. So the Navigation tab will pop up with a few tabs, agents, with all the settings, areas, bake, object. And in the bake tab, we'll click on bake and we'll see, okay, our navigation mesh is pretty small because our agent has a radius of 0.5 meters and it will not fit through the hallway and the bathroom. So the easiest way to solve this is to reduce the radius to 0.2, click on bake, and this already looks pretty good. We have a navigation mesh, and that's navigatable. Save it. Right click in the hierarchy, 3D object sphere. No, I think we dropped the sphere. I would like to have a cube here. Right click, 3D object cube, and this will be our target cube. 0.2, 0.2, 0.2 in the scale to make it a little bit smaller. Reset the position and then move it to our target space. I'd say the bathroom, maybe the toilet will be a good opportunity. Move it 1 meter up so it's above the floor and create a new material for this. We call it the target, and we'll just, what color do we want to choose? I would say green would be sufficiently, make it a full green. Here we go. You can also use some kind of unlit color. I'll just leave the standard shader here, as it doesn't really matter, and it helps us to see some kind of helps us to see the cube better. Cool. Let's rename it to target cube. We can make it static too. And what would be the next step? Well, we can navigate, we have a target, but we still need some kind of indicator, so we create a new game object, call it indicator, and beneath this indicator we create a new 3D object. This time we'll go with a sphere, call it indicator sphere. And create a new material. Here we go, indicator, and let's make the indicator blue. Standard shader is also sufficient here. Make it full blue. Here we go. Add it here and change the scale to 0.2. Move it 1 meter up. I guess it's too small. Make it 0.3 and move it to our origin. The indicator is not at the origin, 0, 0, 0, so the indicator will always be where our application will start. And we want our indicator to follow our target, so we'll just use a position constraint instead of some kind of script. Add it here, click is active, and under constraint settings uncheck the Y part. This is basically very important, because although this property's name is freeze position axis, it just tells us that the position constraint can change each axis which is checked. So in this case, the position constraint can change our x-axis and z-axis, but it cannot change the y-axis. That's what we want. We want to move in the z and the x direction in case of our minimap, but not in the y direction. And now we add some source. As our source is the AR camera as it's moving through our room. And that's basically the setup for a position constraint. And nevertheless, we need something to visualize it, so we add a line renderer here. And we see that the material is pink, so we just create one, add a new material, call it line, make it unlit and color, and adding a color, I'll just add my favorite blue color for lines is 80, 80 and C8. Some kind of bluish color. Add it to the line renderer of our indicator under materials. Add line, here we go. And it's basically very wide, so we reduce the width to 0.1. Just fiddling around a little bit to make it as accurate as possible. And there is still a preview, so we'll change the second position to 0, 0, 0, that it's not visible. Nice. This looks good. In the lighting settings we can cast shadows off, receive shadows off. It's not necessary for us here. And basically have a line here. This line will indicate our way from our current position to our target and will be tracked via the AR camera. So nevertheless, we need something that displays our minimap, so we add a camera as child of the indicator, call it top-down camera. And in this camera, we'll just rotate it to look downwards, 90 degrees in the X direction. Make the projection orthographic and move it up about, I don't know, let's say 5 meters. Doesn't matter because it's orthographic. And make the size, let's play around a little bit. Yes, I'd say around 1 would be pretty nice. Here we go. And this camera will render its image here in the preview, and we want it to render it in a designated target texture, so we can display it within our application. So in the assets folder, create a new folder, call it render texture, and within this folder add a new render texture, create and render a texture. Call it minimap. All the default settings are basically fine. You can always change it if you want to, but we'll just go with it. And add the render texture to the target texture, and as we see, the camera is already rendered here. So we have nearly all of our parts finished. The environment will just add a few layers to configure our environment. I'll start with layer 8 and make a floor layer. On layer 9 it will be a wall layer, and so on. Just feel free to add layers as much as you want for configuring the visibility, and in our AR camera we'll just uncheck the floor and the wall. I'm not quite sure if this will work like I'm intending to, but we'll see. I'll make sure to watch the video until the end to check for possible mistakes. Our top-down camera should render everything. No, I guess we can omit the UI here. Just omit it. We'll see, we'll change it later on. Okay, nice. The next part of the minimap will be our UI. Just go to UI, add a raw image. I'll rename the canvas to minimap canvas. And in the raw image, in the texture part, add our render texture. And if we switch to the game view, I'm just changing the aspect to portrait to get a better understanding of how it will look on our smartphone. We already see the pre-rendered picture, but the size is not very good, so we can either change the scale factor. I would not recommend that because it will change the scale of all child objects. Just leave it at 1. Or in the raw image, change the scale here. But changing the scale is always, well, let's say it's not always the best solution. Basically, changing the width and the height is way better. Leave it at 500 times 500. Well, that looks pretty neat. I'm changing the anchor to centered and 0 and make the Y position, I don't know, 400. Oh, it's a little bit too high. 350 maybe. 300, yeah. That looks nice. I guess we'll just stay with that. And yeah, that's basically our minimap. That should work like intended. Raycast target is not necessary. So let's add a new folder in the assets folder. Call it scripts, and we'll add the one very short script here. Instead of typing everything, we'll just call it set navigation target. I'll just provide the full code and we'll talk about it. I think that's way better than type all the variables and everything by hand. I'll just copy it in here. Here we go. just adding the missing usings for navigation, unityengine.ai, do a little bit of formatting that it looks neat. Here we go, and make it a little bit bigger. What do we have here? So first of all, a field for the top-down camera, a field for the navigation target, the navigation mesh path that will be calculated. Our line renderer could also be a serialized field, it doesn't matter, and a line toggle to start and stop the calculation, create a new path, get the line renderer component, and every time we touch the screen, the line toggle will be toggled, and if it's true, the nav mesh will calculate our part from our current position to a nav target and configure the line renderer accordingly and just enable it initially. Well, this is not the best script, but I think everyone can understand what it's doing. Wait for Unity to compile everything, and I guess that's it. Adding the script to our indicator down here, set navigation target, the top-down camera, adding the child here, and the nav target object is our target cube. Here we go. And let's think about it. Do I have forgotten anything? Well, I guess I just try and cut the video, and after trying I found out that the display is not right of our floor and wall because I forgot to set the layers. So add the layer for floor cube to floor and the wall cubes to wall. And then let's see, we have to adjust the geometry a little bit, move the cube a little bit right here, right over here. So my estimated map is not working that good. Just doing a little bit of movement to get the correct values. Wait over here, and maybe we should move the walls too. Let's see, I'll try it and cut the video here. Yes, okay, after trying everything we have to move the walls too. Just make this one smaller. Here we go. And wait over here and make the bathroom a little bit bigger. I thought it is smaller, but yes, that's not the case after all. And move the cube to 0, 0, 0 to the same level as the starting point. Just slight adjustments here, feel free to do them as you want. And refresh our navigation mesh, click on bake again. Well, this looks pretty good. Maybe the cube should be a little bit more in the center, I don't know. I'll try it and come back to you in a moment. Okay, here we are again, and let's see our AR camera. We just missed to display the walls, as I thought something will go wrong. And okay, serialized property. I guess that does not count to anything that we've done here. Just checking the culling mask again. This looks pretty good. Maybe we should move the environment down about 1 meter because our starting point will be about 1 meter above the ground. Minus 1. This is a very crucial moment because we're changing the environment here. So actually you can recenter your environment, for instance, by scanning a QR code or something else. I'll just do it manually here, so everything will be easy. When you look for something like QR code scanning, I can totally recommend the ZXing QR code scanner. It's very easy to integrate, so, but that's another story. Just Google it and I'm pretty sure you will find something that will work. So, this now looks good. I guess that's everything. Just checking if this will work out. Okay, file, build settings, and again build and run on my good old Google Pixel 2. I have a newer device to test, but I just wanted to show that it will also work on older devices. And here we go. Starting the application, the minimap already is working pretty nice. The feature detection of ARCore is also pretty good, tapping the screen after getting up. Sorry for the mess. And I'm moving, and you see the minimap on the ground moving too. And here we are in the bathroom where our cube is located. I'll just go backwards, trying not to stumble upon something. And in the bedroom, I'm trying to move around a little bit to show that the tracking actually is pretty good. Here we are. Nice, still where we left it. Turning around, and that's it. So thank you for watching. Please like and subscribe, and leave a comment if you want to see more of these short tutorial videos. So thank you and see you soon. Bye.